Hello, everybody. I know I jumped the gun. Now it's 2 o'clock. Welcome. We are going to get started in less than a minute, but the chat room is open. If you want to say hello, you can do that. If you are a class or a homeschool group or a family or anybody, please do let us know. Say hi. Let us know where you're watching from. Sometimes we get people from all over the world joining us for our programs. And we will get started at 2:01. All right, what I'm going to do is I'm going to do my spiel as people are still logging in because my stuff's never is the important stuff or the interesting stuff. So as I was saying at the beginning, my name is Veronica and I work at Idea Exchange. So excited for you to join us virtually for Sea Monsters. This is going to be a amazing program and I'm super excited to learn from Dr. Michelle today. Before we get started, I just have a few quick housekeeping items to go over. Oh, we have some people from Edmonton and the UK. Welcome. Before we get started, I just have a few quick housekeeping items to go over. First, the chat room is open. So you are more than welcome to use that chat room throughout this entire program. You can write your questions in there, any comments or anything like that, you can use that. For those who are watching on YouTube, you can just put any questions or comments in the chat there and I will bring them over. So don't worry, I see your questions. And if for whatever reason, all of a sudden you can't hear, you can't see anything, it is probably just Zoom acting up. So all you have to do is just quickly sign out of Zoom and hop back in again. And that should fix all the problems, hopefully. Sorry, my cat is rubbing up against my computer. Without further ado, I would like to welcome Dr. Michelle. She is going to be leading today's program, and we are super excited to have her with us. So welcome. And Minnie says hello as well.
Hi, Minnie, and thank you very much, Veronica. Well, I'm so happy to be here today. So as Veronica introduced me, I'm Dr. Michelle. So I am the science advisor at the Canada Science and Technology Museum. It is a very cool job. It means I get to work on all aspects of science and technology. I get to learn about trains. I get to learn about mining. I get to learn about the earth. But my particular specialty is actually in paleontology, and that means that I research fossils, and fossils are just anything that was alive a long time ago, essentially, before humans came around. So you can have plant fossils, you can have dinosaur fossils, but of course you can have bug fossils. But I like, in particular, fossils that come from water. So get into the chat, and I want to know, is there anybody in the audience who likes to swim? Do you like to go on boats? Do you like to go scuba diving? Do you like to go water skiing? Or do we have any water sports enthusiasts? I personally love to swim. I like every kind of water sport there is. I like to go scuba diving and snorkeling, and I like to play on the water, and I have been swimming for as long as I can remember. In fact, I even like to go swimming in some circumstances that maybe other people wouldn't like to go swimming in. I like to go swimming with sharks. Here's a picture of me from a couple years ago going down to the Caribbean to actually swim with sharks. And it was really cool. And I thought it was going to be scary, but it wasn't actually all that scary. So knowing that I like to swim with sharks, and I don't find that too scary at all, I have a question for you in our audience. Let's say that we could go back in a time machine and we could rewind the clock about 200 million years to the time of the dinosaurs. So the time where T-Rex is wandering around and Allosaurus and all these big scary things. Would you go swimming in the time of the dinosaurs? What do you think? Dinosaurs, for the most part, as far as we can tell, all lived on land. So there shouldn't have been any dinosaurs in the water. So theoretically, the water's safe, maybe. What do you think? Now, if we look at Canada today, I'm seeing some no ways coming in. No way, Jose. If we look at Canada today, we don't have any seas that prehistoric sea monsters could live in. If you go to the middle of Canada, it looks a little something like this. There's a lot of grass and not a lot of water. If you go a little further north or a little further east, we have a lot of forests. And, you know, there's some lakes in there, but still not a lot of ocean water for things to go swimming in. Or maybe something like this, you know, there maybe used to be a river here, but there's not anymore. And really the biggest bodies of water we've got in Canada today are our Great Lakes, which have some pretty big fish, but not really any sea monsters. So if I were to go swimming in that, no problem, not scary at all. But let's take our time machine back. Let's go back in time about 200 million years. We're spinning and now we've landed. So we've landed here in the Triassic period. So this is about 220 million years ago on this map. And this is right at the start of the time of the dinosaurs. So the very first dinosaurs were around in this time. Now there's a couple things I want to orient you to on this map. First of all, this little red area, this is Ontario. That's Canada there. It looks a lot different than it does today, right? You can see that North America, which is kind of the bit around our red blob, is still attached to South America and also to Africa, which is still attached to Asia. Everything's kind of clumped together. And it's in one giant big continent called Pangaea. And all around that, we have the biggest ocean the world has ever seen called Panthalassa, which basically means all of the seas, because they were all combined into one really, really big ocean. Now, a couple of things going on in Canada at this time. If you look on the western side of Canada, we have a couple of basically islands of land that kept crashing into the west side of Canada during this time. And that's what's going to build up the Rocky Mountains that are on the west side of our country today. If we look at the weather during this time, well, it's actually pretty hot. The world had just recovered from the biggest extinction ever in the history that we have seen on the planet. So more things died at the end of the Permian, so right before the Triassic, than any other time in the planet. And because there's not a lot of plants around, and also because of that extinction, there's an awful lot of carbon dioxide in the air. And we've all heard what carbon dioxide does. If you put a lot of carbon dioxide in, it increases the greenhouse effect, which makes your planet warm up. So this was a big kind of greenhouse effect happening in our Triassic period. So much so that the whole world was about 10, sometimes even 15 degrees warmer than it is today. Now, what happens when it's really hot? Well, when it's really hot, ice and snow melt. So if you look on this map, you'll also notice there's no white. That's because we have no polar ice caps. And so all of that is water instead of ice, which means the sea levels were also a fair bit higher. So this is what we've got. We've got Canada, that we have the beginning of the Rocky Mountains. It's quite warm. It's actually much nicer to live near the Arctic. You can see that's where all the green is because it's a lot wetter. It's a little bit cooler. And we think as well that the center of Canada was very, very dry and arid, kind of like a desert, but that maybe got some regular monsoons. So these really big storms that happened every so often. Now, if we zoom in a little bit to Canada, here we go. There's Ontario again, outlined in red. This is what Canada is looking like right at the beginning of the Triassic. So the very, very first dinosaurs, as we said. So dinosaurs like Plesiosaurus here. Now this Plesiosaurus, this is one of Canada's first ever dinosaurs. It was discovered in Nova Scotia, and we think it's one of Canada's very, very oldest dinosaurs that ever lived here. But what I'd like you to do is look on the left side of the map, on the west side of Canada, and you can see over what is now British Columbia, we've got this little inland sea. So we've got kind of this water that's covering right at the edge of the map here. And this is where we're going to find some of our very first sea monsters. And these are called the Ichthyosaurs. So Ichthyosaurs, if you look at them, they kind of look like a dolphin. but they're actually a reptile. So they're more closely related to something like a lizard than actually a dolphin. Now, our ichthyosaur, and that name actually means fish lizard or fish-like lizard. These are the first really big group of reptiles that ever jumped into the water and kind of took over. So they're our first group of sea monsters, and they lived for a really long time. They lived for the whole amount of time just about the dinosaurs lived. And ichthyosaurs came in a whole bunch of range of sizes. You could find them as small as, say, like your arm, to as long as a big bus or a truck. Okay. Now, the one thing that's pretty consistent about ichthyosaurs is you can see they all have very, very similar shapes. Some of them are a little longer and skinnier, but they're all kind of these torpedo-shaped animals. They have these powerful tails that they use to swim through the water. And another interesting thing about ichthyosaurs is they were actually discovered by kids. So the first ever ichthyosaur that was discovered and described to science was found by two children, Mary Anning and her brother Joseph, who were 12 and 15 when they made their discoveries. Now, a couple more things about ichthyosaurs that made them really, really good at being sea monsters during this time. We have a really good idea of what ichthyosaurs looked like and how their bodies worked because we find really, really excellent fossils of ichthyosaurs. And I've put up an image of one here. So if you look at their flippers, you can actually see that they've got loads and loads and loads of bones in their hands. So imagine taking your hand, and if you look at your fingers, my baby finger here has 3 segments, right? All of my fingers have 1, 2, 3, 1, 2, 3, 1, 2, 3 segments. Now imagine taking those segments and adding like 15 more. So I have segments of fingers that are like 20 segments long. Really, really, really long fingers in their hands, which give them really long flippers, which can help them swim and to steer. And these powerful tails in combination with these flippers could help them go maybe even as fast as 40 kilometers an hour, which is really, really fast. That's, faster than a human could ever run. They also have these really great big eyes, which we think help to see them really, help them to see really deep in the oceans. Yeah, and in Canada, we have a pretty good world record as far as ichthyosaurs go. So this particular ichthyosaur here, you can see it laying on the ground, is called Shonosaurus. And it is the biggest ichthyosaur that has ever been discovered. It is actually the biggest reptile that lived in the water that has ever been discovered. And that comes from British Columbia. So that comes from the furthest, most western part of Canada. And you can see a couple people here for scale. But to give you an idea of just how big this thing was, it's as long as if you took 4 houses and stacked them one on top of another. That's how long this animal was. Another way to think about it, if you wanted to take a little nap and just lie down inside of its mouth, you could be super comfortable on its tongue and not even touch any of its teeth. That's how big its mouth was. Now, we think perhaps that these animals might have lived in groups or pods, similar to like a whale or a dolphin, because some of the places where we find their fossils, we find like 30 of them all together, that they all died together as a group. We're not 100% what would have caused all these animals to die at the same time, but there are a couple theories that you can ask me about if you're curious later. Now, this particular animal might look really scary because it's really, really big, but we actually have found the poop from this animal. And poop is great when you're a paleontologist because it tells you exactly what this animal was eating. And so we know this thing mostly focused on pretty small, squishy fish and squid. So you probably would have been pretty safe actually swimming in the seas next to this guy. Now, if we jump back in our time machine and we go forward in time from the Triassic, we get to the Jurassic. So dinosaurs are pretty well established by this point. We have in Canada things like our Allosaurus here, and we also have sauropods, so these long-necked dinosaurs. Now, again, if you look at the western side of Canada on the left, you can see that we have this big inland sea. So the water is kind of spilled over the continent and goes all the way down into the United States. And we call this sea the Sundance Sea. And in that sea, one of the most common types of sea monsters you would have found are plesiosaurs. So has anybody ever seen a picture of the Loch Ness monster with the 4 flippers and the really long neck? This is what we think it was kind of imagined after. So plesiosaur means near lizard or kind of lizard-ish. Because when scientists first discovered it, they thought it was more similar to a lizard than it was to the ichthyosaurs, or those fish lizards we just looked at. Now, one thing that's pretty unique among this type of sea monster, the plesiosaurs, is they swim with 4 flippers. So almost everything else that has ever evolved to swim in the ocean swims with its tail, and it swims along and pushes itself using its tail. So our whales, our dolphins, the ichthyosaurs we just looked at, fish. But these guys actually swim with their 4 flippers. And that's really, really unique. And one of the only other groups to ever do that is actually sea turtles, which of course we still have alive today. Now, if we look at our plesiosaurs come in 2 flavors. So if you think you have like chocolate and vanilla ice cream, well, we have 2 flavors of plesiosaurs too. So they both have these 4 flippers, but we have our kind of pliosaur-like plesiosaurs, which have these really, really big heads and pretty short necks. And we have our elasmosaur-like plesiosaurs, which have these really, really long necks, but really, really teeny tiny heads. Now, which one do you think you have to worry about? The answer is almost always the one with the bigger mouth and the bigger teeth. So in this case, our pliosaur-like plesiosaurs. So we're looking at this guy. These guys could get really big. We're talking the length of a bus here. And their teeth could actually, if you hold your hand up, get almost as long as your hand. So if you imagine them taking a bite out of something, the teeth are going to go all the way through, right? They're really, really big. These guys are top predators, which means they go out, they hunt, they bite other big animals that are swimming around. They'll eat fish if they can get them, but they're really after big prey. So these are the guys you do not want to be swimming with, because you would probably be considered a snack. One interesting thing about them, though, is we think they were actually pretty good parents. So even though they were big and scary and they were hunters and they could track you down and swim faster, they had little babies that we think they actually raised. So we found fossils of moms with babies in their bellies. And we know that they gave birth to a single offspring. So just one, just like humans do. So humans usually give birth to one baby, and they take very good care of that baby until it grows up. And we think plesiosaurs probably did the same thing, because we know they gave birth to one baby. Now, just like how Canada had a world record for ichthyosaurs, Canada also has a world record for plesiosaurs. And I'd like to introduce you to Albertonectes. So as the name suggests, Alberto, this guy was found in Alberta. And it has the longest neck ever of any organism that we've discovered so far. Its neck has 76 bones in it. Ours has like 7. So this is a really, really long neck. And you can see a person for scale. Now, even though the neck was so long, you can see the head is still quite small. So it wouldn't really have been a danger to us. It's also probably swimming around eating really tiny fish and squid, because remember, it has to swallow those things after it bites them. So it's really sticking to like soft, squishy things that aren't going to get stuck in its very, 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 very long throat. One last interesting thing about plesiosaurs, though, is you see the little picture of rocks I've put on the screen. We think that elasmosaurs actually swallowed rocks as they were swimming around. They'd go to the bottom and pick one up and swallow it, which would actually have helped to weigh them down in the water, which made it easier for them to kind of swim around. And there's a picture of what we think their head might have looked like. You can see, again, even though the teeth look scary, they kind of stick out from the mouth because that helps them catch slippery fish. Again, it's those really tiny, squishy, slippery fish that they're going for. So we probably would have been safe. Now we're going to get back in our time machine one more time, and we're going to jump forward to the Cretaceous. So this is like the end of the age of the dinosaurs. This is when we see those dinosaurs that everybody's really, really familiar with. So in Canada, we've got things like T-Rex and Ankylosaurus. We've got lots of ceratopsians, so the horned dinosaurs like Triceratops. That's what we're finding all over Canada at this point. But if you look, you can see that once again, we've got this giant big sea in the middle of Canada. That's definitely not there anymore. And we call this one the Western Interior Seaway. Now, this is the one I would definitely not want to swim in. All right. The Triassic seas had ichthyosaurs. They're a little scary. The Jurassic seas had some plesiosaurs and some ichthyosaurs. Probably would have avoided. The Cretaceous seas have ichthyosaurs for the part of it, also have plesiosaurs, but now we get mosasaurs, and these guys are the scariest of them all. So these are related to lizards that we still have on Earth today. Things like the Komodo dragons, the biggest kind of fiercest lizards that we still have. Take that, blow it up in size, throw it in the water, give it some flippers, and that's basically a mosasaur for you. So these guys are apex predators. We have found food in their stomach, including giant fish, sharks the size of great whites, plesiosaurs, turtles, like giant turtles, and also other mosasaurs. So these things are so big and scary and top predatory that they will eat literally anything in the oceans, including us if we were to go in the water at this time. So if there's one type of sea monster you probably want to avoid, it is the mosasaur. So we actually find mosasaurs with bite marks all over their faces, which tells us that mosasaurs were actually fighting with other mosasaurs pretty regularly. So they were they were pretty big and nasty. And then the other thing that's really scary about them is they were found literally all over the world. We have not found an ocean or a sea from this time that did not have mosasaurs in it. They were everywhere. So nowhere was safe. So just if you find yourself in the Cretaceous, just don't go in the water. And like the plesiosaurs and the ichthyosaurs, Canada has a world record holder for mosasaurs too. So this is Bruce. So this particular specimen is the biggest mosasaur that has yet been discovered and kind of put on public display. So this guy is about 13 meters long, a little bit longer. So that's basically the size of a semi-truck. So one of those trucks that pulls the really, really long, big trailers is as big as this mosasaur, okay? So he's way bigger than a T-Rex, and in my opinion, scarier. And he's known as a Tylosaurus. And if you ever find yourself out in Manitoba, you can go visit Bruce, and you can stand beside him and imagine how scary it would have been to, dip your toes in the water and see this thing coming towards you. And if that is not the stuff of nightmares enough, one more thing to tell you is that, let's say you found yourself in the mouth of a mosasaur, and you're like, oh, maybe you're a little fish and you're trying to get away. It's going to be very difficult for you to do this, because mosasaurs, not only do they have the regular row of teeth that most other reptiles have, they also have a set of teeth in their throats. So they have two sets of teeth, and they can move these two sets of teeth independently. So you could be getting bitten by two sets of teeth at different times, back and forth, back and forth, back and forth. And we think that they used them like modern snakes to help kind of ratchet prey back down their throat. So if something was slightly too big for them to swallow, they could kind of like ratchet it back one tooth at a time back down into their throat. So they're pretty crazy things. So yeah, that's basically all I have to show you about Canadian sea monsters today. I want to reiterate that I would not want to get into the water during the time of the dinosaurs with any of these things, but I'm curious if there's any brave people in the audience who would have, or which one you found the most scary. So with that, I will open it up for questions, and thank you again for coming today. Ooh, I'm seeing questions starting to roll in. So how do dinosaurs get their names? Well, this one's pretty fun. If you become a paleontologist, you actually get to make up the name. So this is the same is true for any type of fossil. So if you discover a fossil plant or a fossil bug or a fossil dinosaur, you actually get to come up with the name. And most of the time, the names should tell you something about the animal that was discovered. So for example, Alberta nectes tells us that it comes from Alberta. Something like Shonosaurus, which is a type of pliosaur, is named after Kronos, who was one of the Titans from Greek mythology. So that just gives you an idea of how big this thing was. Ooh, someone's saying, I like plesiosaurs. I like plesiosaurs a lot too. Mosasaurs have a little special place in my heart, just because I think they're the scariest, but I love all of these ancient sea monsters a lot. How many plesiosaur fossils have been found? I can't give it a number. It's a lot. You gotta remember that when you find fossils, most of the time we just find like a tooth or a bone. It's pretty rare for us to find an entire skeleton together. And so an entire skeleton, you could probably count probably less than 100 worldwide, but pieces, there's loads and loads, like tens, hundreds of thousands, like so many that you'd never be able to count them. Ooh, another question, Dunkleosteus. So Dunkleosteus is a pretty scary looking sea monster in and of itself. So Dunkleosteus is actually a fish, and it is a fish that comes way before the time of the dinosaurs. So Dunkleosteus went extinct long before any of these reptiles that I talked about. But Dunkleosteus, his head was about from my waist to the top of my head. So, you know, he could definitely fit most of my body in his mouth, and about as long as a car. But it was a pretty cool looking fish, because if you imagine like a fish but put like a big like football helmet on it, that's kind of like what Dunkleosteus was. So he's a type of fish called an armored fish, because, you know, the scales kind of fuse into these armor around its head. Do plesiosaurs mate for life? I wish we knew the answer to that one. So that is unfortunately a question we're probably not ever going to be able to answer, because it would actually rely on us having a time machine to go back in time and make that guess. Now, the reason we think that plesiosaurs were good moms and probably raised their offspring is because we look at everything that's alive on Earth today, and most animals that give birth to only one offspring at a time look after that offspring, because that's the only one. So it's super, super precious. So you have to kind of protect it. And so we take our knowledge from today's animals and we kind of apply it to animals in the past. So it is just a guess that plesiosaurs were good moms that raised their babies. We think it's a pretty good guess, but it is still a guess. Whether they mate for life or not, I don't know that we would ever be able to find evidence that would tell us yes or no. What are the longest sea animals? Well, that Ichthyosaur that I showed you right from the front, the Shonosaurus, that is the longest one we've ever found that is an ocean reptile. Today, of course, the blue whale is the longest, and the blue whale is a little bit longer than those Shonosaurs. But even today in our oceans, there are still creatures we don't know the upper limits to their size. So there could be giant colossal squids down at the bottom of the ocean that no one has ever taken a tape measure to, because we've never seen them up close, that could be even longer. What year did the kids discover the fossil? Oh, when did Mary Anning discover her plesiosaur and ichthyosaur? I don't remember the exact date, but it was in the 1800s, I think in the middle 1800s. So we're talking like 170, 180 million, or 180 years ago. So not actually that long ago. You can look up the date later, definitely. Her name was Mary Anning. I can type it in the chat for you here. But yeah, super, super interesting story. And she and her brother basically, they lived in the south of Britain, and they would go out on the beaches and they would collect fossils that they would sell to tourists. And most of the fossils they found were just little like seashell fossils, but every so often they'd find something really, really cool, including some of these plesiosaurs. They also found Britain's first pterodactyls, so the flying reptiles as well. Oh, and I think that's the same question. How big was the tooth from a mosasaur? Well, it depends on the mosasaur. So we have some really, really tiny mosasaur-like animals that, have very, very tiny teeth. But the really big one from something like Bruce, we're talking about the size of maybe not my hand, maybe a little smaller. But most of that would have been the root of the tooth, so embedded within the jaw. And then you have the little tooth poking out. So let's hold up your thumb and you'll say maybe about that size, but probably a little thicker and definitely a lot more pointy. What is the longest sea animal? I think we've answered that one. How long was the one that looked like a snake? Not sure what you mean by that. Yeah, I'm not sure what you mean by the one that looks like a snake. If the person who asked that question can provide a little more explanation, maybe I can help you out there. Veronica, I don't know if I see any more questions. Have there been any more questions coming in elsewhere? What might have caused the dinos to die? So this is still a little contentious, but most paleontologists think that it was at least partly caused by a big extraterrestrial rock that crashed in to the Earth around Mexico. And when you take something that size and you slam it into the Earth, a few things happen. Sorry. The first thing is you're going to get this big fireball, right? Because you have this superheated air that's around it as it crashes in, so that it just makes this like blast of fire, like kind of like a bomb when it hits the ground. You're also going to have giant tsunamis because it hits and it creates this kind of pressure where it hits in the seabed and it makes the water fall and then bounce back up, and then the water kind of goes everywhere. It probably had tsunamis all over the world. You also got a whole bunch of dust that got kicked up into the air. The dust starts to block the sun. When you block the sun, the plants can't live. When the plants can't live, the plant eaters can't live. And when the plant eaters can't live, then the carnivores can't live either. And everything just kind of dies, essentially. So that was a really tough time at the end of the dinosaurs. And that, unfortunately, or maybe I guess fortunately for us, also did wipe out the mosasaurs and the plesiosaurs at that time. The ichthyosaurs had actually gone extinct a little before that. Crocodile shark. I'm not sure what a crocodile shark is, but it sounds cool and probably a sea monster.
I think we got all the questions. Thank you so much. That was so interesting. I didn't realize that Canada was that much underwater.
It's kind of surprising, right? Like we only have lakes today, but we've actually had a lot of seas in our past.
Yeah, and when you showed that first image of the globe, like how different the world looked in terms of the continents or land, I guess, where it was in the world, just blows my mind. But thank you for joining us today, and thank you everybody out in the audience for being amazing as always. Next week we're going back into the oceans, but not quite so far back. We're going to be looking at whales and how they live in our oceans, and so we're looking at nowadays sea animals. So it's going to be a lot of fun. Thank you, Michelle, once again. It was so much fun having you. It was so interesting.
Well, I'm so glad. Thank you so much for inviting me. I love talking about sea monsters. I'm happy to come back anytime.
Awesome. It was great. It was so much fun.